room to the cloud. Okay, so we are now in section 8.1. And so in 8.1, all of chapter 8, we're going to do 4 sections over the course of these 2 units. In chapter 8, chapter 8 is about the discipline of geometry, which I know for some of you might bring back some bad memories. We are not going to go super deep into geometry. We're not going to do proofs or anything like that. We're just going to do enough to get you acclimated to be able to any sort of everyday uses that you might use. So the discipline of geometry was formed out of a need to measure for things like construction. So historically, it's believed that geometry really started to take off with the Egyptians and the Babylonians back in the day when they were making their beautiful pyramids and temples and things like that. They needed to be able to make the angles so that everything would fit just right. The Egyptians were really great practical mathematicians in the things that they did with the geometry and making trenches for water to flow out of the Nile. They just did so much with their geometry. Another use of geometry came for navigation. So before GPS, as you know, people floated along on the waters and they used geometry to kind of see where they were and where they were heading. And then out of that, because people are just curious, out of that, it began to be used for astronomy, to be able to predict the movements of the planets and eventually how the Earth behaved in the universe. So if you ever get the chance to take a history of math class, it's pretty fascinating stuff. There's lots of fun stuff that goes on in the history of math to get where we are. We take so much of it for granted, but for so long of the history of human beings, math was a developing thing and very practically used for survival. Okay, so our basic terms that we have for geometry. Okay, the most basic object in geometry is what's called a point. A point technically doesn't have a definition. There's no good way to define it, but we can think about a point as a location in space with no length or width or height. So we probably have a better conception of this than previous eras in time because we use our GPS and everything so much. A point is just a location more than anything else. It's not even necessarily an object. So then from points, you can develop the whole system of geometry. So then you say a line, okay, a line is a set of points. And any 2 distinct points determine a unique line. So if you have a point and then a second point, the second point determines the direction of the line. So some other objects that are part of our study of geometry, we can look at the idea of what's called a line segment. A line segment is the part of the line between 2 points, including the endpoints. So in a few minutes, we're going to talk about, or not even a few minutes, in a few seconds, we're going to talk about notation. But here's the difference. A line goes forever in its 2 directions. And the way we notate that is we'll put arrows on the end of the line. Those arrows indicate that it never stops going. Okay, the only thing that stops it is the page. A segment has a starting and a stopping place, so you can either do one of 2 things. Normally, you'll just write a segment like that with no arrows on it. But if you really want to be definitive, so people know that it has a starting and stopping place, you just put like a small little dot on the end, like it's a barbell or something like that. So the final thing that I'm going to define for you, and then we're going to start doing a few problems just to keep this at least moderately interesting. The last object I'm going to define for you is called a ray. A ray is a half line that includes the endpoint, like a ray of sunshine. Okay, it starts at the sun and comes right toward us. So a ray, you include the endpoint and then it goes forever in one direction. So you just put an arrow on one side of it. The other side has a dot. Okay, so then the question comes, okay, well, that's great, Perkster, but how do I write these things down so we all know what we're talking about? And that's great. So here's the symbolism that you're going to use when you're letting me know if something's a ray or a line or a segment. So if you have a point A and you want to notate that, you just put like a little dot in front of the A, point A, like that. If you want to let people know that the object that's going through points A and B is a line, what you do is you use those 2 points. Remember, it takes 2 points to determine a line. So you use whatever 2 points you're using, and then you put the little line with arrows over the top of it. Okay, so the symbolism's important. This is a detail. I'm making the effort to go through this because I want you, when test time rolls around, to be able to communicate to me the answer that you are intending to. Now, whereas a line, you could put the points of a line in any order. It would be perfectly equivalent to do line BA because it's going forever in both directions. So it doesn't matter what order you use for those. For a ray, the order is important. What you do for a ray is you indicate a starting point and then the direction the ray is going. So if I write ray AB like this, what this means is that since the A does not have an arrow over it, that this starts at point A and then goes in the direction of B forever. So that would be a completely different thing than if I did this. Okay, so order is important for rays. So I'm just gonna make mention that these two things right here, these are different objects. The first one starts at point A and goes in the direction of B forever. The second one starts at B and goes in the direction of A forever. So those are going to be different things. And you'll see that in a minute when we do some problems and we put some pictures to these things. A line segment, if you want to just tell somebody that you're including all the points between A and B and you're including the endpoints, again, you use A and B, and then you just put a bar over the top of it. No arrows. If you really wanted, like I said earlier, you could fill in some dots on the ends, but I try not to make things too confusing. If you have what's called an open segment means that you don't include the endpoints. So an open segment does not include the endpoints. The way that you denote that is you'll have your A and your B, and then you put open circles on the sides of the little bar at the top. And then last but not least, I'm just trying to give you an example of everything you're going to see when you go through your homework so that there's no mysteries and you don't encounter something and are like, oh, the Perkster never told me anything about this. So half open segment means you're not including one. So a half open segment could look like this. You could have A and B is not included, or you could have A is not included and B is included. So half open means you're only not including one of the endpoints. Okay, so up to this point, that's a pretty exhaustive list of the things that we have that we are going to consider. So here's some problems. So example 1 down at the bottom of your page, I'm going to do the 3 parts to example 1 with you. And then when we flip the page, I've got a similar problem, similar style problem for you. So here's what we've got. I've got AB with a bar over it. So that tells me segment, the segment that starts at A and goes to B. And then I've got segment that starts at A and goes to D. Remind me, because it's been a while, what does this symbol between those two things mean? It's the union. Yeah. Saw that in our first unit. Does anyone remember what the union tells me to do? It includes everything. Yes. Any points that are listed are going to be included. Great. So here we go. Here's my problem. I'm going to start with segment AB. So I'm just so that I don't mess up the picture too much, because we'll need it for all three parts. I'm just going to do these separately. So this is the segment that starts at A and goes to B. So I've just made my little segment right there. And then I'm going to also draw my segment that goes from A to D. So I'm going to start at A, and then I'm going to go all the way over to D. So I'm just kind of tracing underneath the drawing to keep things separate so that I don't make a big mess. So everybody tracking with me what I've drawn here? Even though it's below the line, I've got A to B, and then I've got A to D. Are we okay? Am I confusing anybody about what I'm doing? Okay, so now when I union those, when I smush those together and I take everything, what do I have? Does it go forever in either direction? No. So does it have a starting and a stopping point? Okay, so right away, if it has a starting and a stopping point, that's called a what? Line segment, for sure. And so now I need to define where does it start and stop, because that's the important part of the line segment. So where does this line segment start? At A, here at A, and then where does it stop? At D. Okay, so the answer to this is line segment AD. Okay, so let's try the next one. I know this is funky and goofy, and you might not have done this before, so I don't want to rush through this. If I'm confusing you, let me know. This time we're going to do the same thing. I'm just going to redraw, okay, just so that when you're looking back at your notes later, you can see what we've got. So I'm going to redraw in purple. So again, I've got the segment that starts at A and goes to B. So you can see here's A, and then here's B. I've just lined up my new segment in purple below the original drawing. And then I've got the segment that starts at A and goes to D. So I've got the same segments I'm working with, but this time the symbol between them is different. What's that symbol mean? Anybody remember? It's the intersection. What does the intersection mean to do with my two sets of points? Just the things they share in common. Yes, exactly. So looking at these two segments, I've got the one that goes from A to B, the one that goes from A to D. What do they have in common? Where do they start having things in common? At A, okay, you can see both figures right here at A. Where do they stop having things in common? At B, you can see if you go beyond B, there's only one of the purple lines anymore, so that's not in common anymore. So they start having things in common at A, they stop having things in common at B, and that's a line segment because it has a starting and a stopping point. All right, I've got one more that I'm going to do, and then I'm going to flip the page, and you've got three examples, I think, that you are going to do. Yeah, I've got three for you on the next page. So here's my next one. My next one, I've got segment BC. So it's the segment right here that starts at B and goes over to C. Okay, so I've lined my dots up right underneath the points B and C. We're unioning again. This time I've got a new figure though. This time my figure is CD with a ray over it. So the ray says I'm starting at point C and then I'm going in the direction of D forever. So I'm going to put an arrow on that end. So I've got B to C. It's the first one. Then I've got C in the direction of D forever is my ray. Okay, when I union these, when I smush them together, what kind of figure do you have when I include all those points? What happens? Okay, it's a ray, right? Because it's going forever in one direction. Does everyone at least see that so far? Okay, so it starts here. When I include all these points, it starts here and goes forever in this direction. Where's the ray start? What is that starting point? B. Now here you have an option for a ray. Okay. Whereas for segments, you have no option. You have to give the starting and the stopping point. For a ray, you have to give the starting point, but then the second point is just the direction. So you could say it's the ray that starts at B and goes in the direction of C. Or you could say it's the ray that starts at B and goes in the direction of D. Both of those are the exact same thing. Okay, they both mean the exact same thing. They're both correct answers. Okay, one is not right, one is not wrong. So if you put either of these two things on the test, I would give you full credit for it. Okay, so you don't have to worry if you're choosing the right point. So notice, I just want to repeat this one more time. B has to be included because it is the starting point. But then C or D, you have the choice because both of those are in the same direction relative to point B. Everyone tracking with me so far? We still doing okay? All right, then I'm going to give you 90 seconds or maybe 2 minutes to do exercise 1. It's the same figure we just used, but just 3 different problems. All right, so the first one says I have a ray that starts at B and goes in the direction of C. So the ray starts at B, it goes in the direction of C. So I'm just going to draw a nice ray like that in the direction of C. And then I'm intersecting with the ray that this time it starts at D. So I'm going to make a dot here at D and it goes in the direction of B. So I'm going to draw a nice long ray this way. Everybody good with what I'm drawing? We okay? You seeing? Let me know, okay? Don't let me move on if you don't. Intersection, so what do they have in common? So where do they start having stuff in common? They do have stuff in common at C, if that's what you said. Wasn't entirely sure. I also heard B, yes. So notice here at B, they have both of the figures. Over here to the left of B, there's only one of them. So they start having things in common at B. And now as I truck along on the line, okay, where do they stop having things in common? Where do both of them stop existing? At D. Notice if I go right of D, I only have one of the rays. So again, I've got a starting and a stopping point. So what kind of figure is this? It's a what? I think I heard somebody say line segment. Yes. Thank you. Appreciate your help It's hard for me to hear sometimes with the ginormous wind going on in this classroom for some reason. Okay, so then the next one I asked you to do was a union problem. This time it's ray that starts at B, goes in the direction of D. So even though it's named different, it's the same first ray as the last problem. And then we've got the ray that starts at D and goes in the direction of B. So it's the same second ray as the last problem. So this time we are unioning instead of intersecting. Union means I'm including everything. So what kind of figure do I have when I'm including everything? It's a line. Notice it's going forever to the left because I'm including this stuff here on the left, and then it goes forever to the right. So it's a line. Now here we might all have something different. This might be a question you ask. How do I denote this line? Which letters do I use? And remember, how many points does it take to determine a line? 2. So it doesn't matter which ones. A segment, remember, you have to include the endpoints. A ray has to be one of the endpoints. The other one, you just need the direction. So here you could have written that this is line BC, or you could have said it's line AD, or you could have said, I'm not going to do all of them. This will be the last one. You could have said it's line BD. And there's a couple other options that you could have. Okay, as long as you picked 2 different points and put that line symbol above it, you got it right. Don't put 3 points. Okay, don't put A, C, D. Okay, that's not good notation. Okay, so only 2 points and then the line symbol above it. Okay, the last problem that I asked you to do was segment AC. Union segment BD. So segment AC starts at A and goes in the direction of C and stops at C. And then BD starts at B and then goes to D and stops. When I union these, I'm taking everything. So what do I have? What kind of figure do I have when I take the union of these 2 line segments? Another line segment. Where is my new line segment going to start? Over here at A, sure. And then where is my new line segment going to stop? Yep, D. And then I'm going to put the line segment symbol at the top. So you have to use those 2 letters for the answer to that problem. You can't use other letters on a line segment. You have to indicate the starting and stopping point. So that's about as much fun as we can have with line segments, because you can see that in those problems that we kind of got a little bit repetitive and we're using the same rays and stuff. So what we're going to do is we're going to increase our number of dimensions from 1 dimension to 2. So a plane is a 2-dimensional surface. So what I mean by 2-dimensional is if you look at the whiteboard, we can go up and down on the whiteboard, that's 1 dimension, and then we can go left and right on the whiteboard, and then everything else is combinations of those 2 things. So that's what it means to be 2-dimensional. When we come back in the next unit, we're going to talk about space, and space has 3 dimensions. Okay, you can go, if we're walking, we go front and back, we can go left and right, and we can jump up and down. So there's 3 dimensions in space. So a plane is a 2-dimensional surface that extends infinitely in both directions. So our whiteboard here at the front of class, that is a plane, but a geometric plane goes forever. So you'd have a giant whiteboard that never stopped going up and down and left and right. Okay, so any 3 distinct points that are not on the same line determine a unique plane. So when I bring my camera to class, when I'm actually writing at the whiteboard, you notice I put my camera on a tripod. It has 3 legs. That's why tripods, if you like to take pictures, then you know this. That's why tripods have 3 legs instead of 4 or 5 or 6, is because since it has 3 legs, any surface you put the tripod on is going to be stable. It's not going to rock on you, so you don't have to worry about vibrations in your pictures. And so you can adjust the lengths of the sides of the tripod for when you're on an incline or when you're on a rocky place, so that it will always be stable. That's why when you go to Panera Bread and you're sitting at one of their tables outside, you never notice that the tables rock, right? And it's very annoying when you're putting a drink on the rocking table. Well, what's happening there is one of the legs on the table is shorter. So what the table is doing is it's rocking between two planes. Okay, on one position, it's on 3 of the 4 legs, and then when you put your drink on it and it moves, it tilts to the other 3 of the 4. So it's alternating between two different planes. So 2 lines in the same plane that do not intersect. Now this is probably a word you've heard before. What are 2 lines that don't intersect called? Anybody know that word? Boom, yes. They're called parallel lines. When you have 2 lines in the same plane that do not intersect, they are parallel. They always stay the same distance apart. So we have another figure that we're going to use for some fun problems. And so the first 2-dimensional figure that we're going to talk about is called an angle. And an angle is created from the union of 2 rays that have a common endpoint. So if we fuse 2 rays together at their endpoint, you come up with what's called an angle. And that endpoint that is common to both of them, that's called the vertex of the angle. The symbol for an angle, again, math people love symbols because we don't like to write things out. We're pretty lazy. The symbol for an angle is just this right here. It's a symbol, angle. And then you'd say angle ABC. You could also say angle CBA. The thing that's particular to an angle is that the letter in the middle has to be the vertex. So as you're hopping around the points on the side of your angle, the middle one is always the vertex. So when we're reading these angles for the problems that we're going to be doing here in a minute, just know that that middle point is always the vertex. So for instance, exercise 2, I'm going to do the first one, and then I'm going to let you attempt each of the next one. So exercise 2. What I want to do is I want to see angle FCD. So we're going to go from F to the vertex of C to D, and we're going to intersect it with angle HCD. So I'm going to go ahead, I'm going to trace on our figure here the best that I can. I learned in my last class that what I probably should do is put multiple of these figures so that it doesn't become too much of a tragic mess. So I'm sorry that I'm learning on the go with these worksheets here. So FCD, so that is the angle that starts at, or doesn't start. F is on one of the sides, C is the vertex, D is on the other side. So it's this angle right here that I'm tracing in purple. This is FCD right here. C is the vertex. And I'm going to intersect that with HCD. Now I'm going to do this in a different color just so that we can see what's going on. So HCD, so H is on one of the sides of the angle, C again is the vertex, and D. So it's this angle right here. So I'm just, this one that's kind of in a pink. Probably should have used a more distinct color, but it is what it is now. So when I intersect those 2 things, what's in common there? I'm sorry, what'd you say? C is in common, but in fact, we have a little bit more than C because we have this whole side of the angle in common right here. Okay, so since I have from point C all the way in this direction, I have a, what's that called? It's not going to be a segment because the ends of an angle are rays. Remember, the angle is 2 rays. So each of these angles continues going forever and ever. That's why I put little arrows. And I know it's hard to see on my messed up figure. So what I'm going to have is, just as I was told, it starts at C and it's going to go in the direction of D, and it's going to be that ray. Basically, we've just chopped off those two angles when we set them next to each other. All right, so give the next one a try, see how you do. I'll give you about 30, 35 seconds to see if you can figure out what is formed when we do the next union. Okay, so the next one says I've got ray FI. So I'm going to do this in green. It's the ray that starts here at F and goes in the direction of I. Okay, so it's a ray. I've put an arrow on the end. And then ray FG, again, is going to start at F, and then it's going to go in the direction of G. So this is purple. It's going here. So what do I get when I union together this green ray and this purple ray? What kind of figure is that? It's an angle. And then any hypothesis of what I'm going to call that angle? Yeah, it's either going to be IFG or it's angle GFI. The F has to be in the middle. Also, you can't just call it angle F because there is 8 angles at F, so we wouldn't know which one that you're talking about. Okay, so you have to put all 3 letters as the answer to that. Okay, try the next one. Ray AC intersected with ray EF. Okay, so ray AC, I'm going to do in purple. It starts at A and goes in the direction of C, so that ray right there. And then ray EF, I'm going to do in orange. It starts at E and goes in the direction of F, like this right here. So what do I get when I intersect those? What do they have in common? I'm sorry, I just didn't hear what you said. So in common, so I've got this purple one, starts at A and goes in the direction there. And then E starts here. So what they have in common, they don't have the A and the E in common. Those 2 things are not part or both. It's only point B, right where those 2 rays cross over. So the only thing they have in common is point B. All right, last one. And sorry that the drawing is such a mess. You can redraw it. In fact, maybe I'll do that while you're working the problem. I'll redraw this. So what is angle ABE intersect angle FBC? All right, angle ABE, I'm going to trace in orange here on my new drawing that I did at the bottom. It's the same drawing that I did the best I could freehand. So it is this right here that I'm tracing in orange, ABE. And now I'm going to intersect that, and I'm going to trace this in blue, FBC. So it's F to B, and then goes in the direction of C. So it's this angle right here in blue. And we're intersecting again. So what do those 2 angles have in common? Yeah, again, they just intersect right there at that point. So point B. They have the same vertex, and then they go in different directions after that. All right, we're doing good. You guys are doing great. I appreciate it. We got one more page here. So we started talking about these two-dimensional figures called angles. So angles get categorized based on how large the actual angle is. So the first kind of angle is called an acute angle. And an acute angle has a measure that's bigger than 0 degrees because there has to be an angle there, and it's less than 90 degrees. So if you have an angle that measures 35 degrees or 24 degrees, any number between 0 and 90, that's what's called an acute angle. The next kind of angle is called a right angle. Right angles are exactly 90 degrees, like hopefully the floor and the wall are right angles. Otherwise, we should evacuate the building. The next kind of angle is called obtuse. An obtuse angle is bigger than 90, but it is less than 180 degrees. So for instance, if you look down the page to the diagram that's just to the left of exercise 3, angle ABC is an obtuse angle. And in fact, ABD is an acute angle. Okay, so that's the difference. And then finally, although this designation doesn't get used too much, a straight angle is 180 degrees. That's also just a straight line. So usually it just gets called a line. So those are the different types of angles. And for our next couple problems, we're going to use this relationship between two angles. Two angles are called complementary. They're called complementary if the sum of their measures is 90 degrees. So in a moment, we're going to do example 2, and we're going to see two angles that have been glued together that add up to 90 degrees. And then two angles that add up to 180 degrees are called supplementary. Okay, so my next example, example 2, is going to go like this. Example 2 goes with this figure that's on the right. So it says in this figure, angle DBC, so D to B to C, and ABC, so A to B to C, they are complementary. And complementary means they add up to 180 degrees. Sometimes in pictures, you'll see when angles add up to 90 degrees, or if you have a right angle, you'll see a little box put in the angle that indicates it's 90 degrees or that they're complementary. So if the measure of angle ABC is 34 degrees, so I'm going to put a little 34 degrees in there. What I want to know is what's the measure of this angle right here? So I'm just going to put a question mark. What's the measure of that angle? Now, I know that you can all, I'm sure everybody could pop out their calculator and figure this out real quick. I'm just going to set this up in preparation for a future exercise, okay, that might be a little bit harder to just do mentally. Okay, so again, I know you could probably do this mentally, and I have no problem with you doing it that way. But since they are complementary angles, here's what I know, is that my question mark, that angle, plus the 34-degree angle equals 90. And so now, seeing that, you can see pretty clearly, what am I going to do to figure out what the question mark is? What am I going to do with the 90 and the 34? You're going to subtract them, yeah. So 90 minus 34 gives you that the missing angle, the angle DBC, is 56 degrees. So please do me this favor, exercise 3, same sort of thing. Go ahead and this time, though, the picture is just to the left of exercise 3. I tell you that those two angles are supplementary. All right, in this figure right here, we are told angle DBA, which is this angle right here, and angle ABC, which is this bigger one right there, are supplementary, meaning they add up to 180 degrees. If ABC is 115 degrees, I want to figure out what's DBA, so question mark. So again, I'm sure intuitively you could figure this out, but my question mark plus my 115 degrees equals 180. And so hopefully in your calculator, you subtracted those two things and you got 65 degrees. Everybody tracking with me on that? All right, well then give exercise 4. The reason I set this problem up like this is in preparation for exercise 4. Give it your best shot and see how you do on exercise 4. All right, so I'm going to relabel my figure. So in exercise 4, I tell you the figure in exercise 3 that we just used. I'm declaring to you that angle DBA and ABC are supplementary, so they add up to 180 degrees. But this time, instead of giving you a definitive number, I tell you that ABC is X. So in pink, I'm going to put an X for this problem right there. And DBA is X minus 30. Okay, those are the expressions for both of those angles. So now I'm going to figure out what X is. Okay, so my first angle, angle ABC, is X, plus my second angle, DBA, which is X minus 30. I know when I add those two angles together, I'm going to get 180 degrees. So that's the setup. This is as much algebra as I assume you know how to do in this class. Okay, this is the max right here. So in this particular problem, I've got X plus X. What do you get when you add X plus X? What's that give you? 2X, thank you very much. Then minus 30. There are 2 steps that will allow me to finish this problem. In fact, just so that I don't go down into that line we're about to fill out, let me move my problem over to here. What's the first step to solve this problem? Yeah, I'm going to add that 30 to both sides. Perfect. And so that leaves me with 2x is equal to 180 plus 30, which is 210. And then what's the second step to figure out what x is? Yeah, I'm going to divide by 2 on both sides, and then I get x is equal to 105 degrees. So in that case, we could then figure out what both angles are, but that particular problem just asked us to figure out what x is. So x was 105 degrees. All right, you're doing fantastic work. We're almost done. You're going to survive this section. The last thing we're going to talk about that relates to angles and relates to what's going on is parallel lines. We defined parallel lines earlier to be 2 lines that don't ever intersect when they're in the same plane. So in this figure that we have right here, the 2 blue lines are parallel. And you notice you've got a pink line that cuts through them. So a line that cuts through 2 parallel lines is called a transversal. And the fun thing for us is the transversal creates all sorts of angles and angle relationships right here. But here's what I'm going to do, just because we have like 6 minutes left, and I don't want to rush this because it's really not super hard, but I don't want to be talking really, really fast. We're going to stop here, and we will finish the rest of this at the beginning of next time, and then we'll finish up our other section.